Hey folks, it's Jim here at Science Talk. In this video segment, I wish to discuss with you some of the risks to food security, because indicators are things are starting to unravel. So, this is a study that was published in the journal Nature Climate Change. It was led by primarily a French scientist, but it's through the Food and Agriculture Organization of the United Nations, FAO. The Director General of FAO is Jose Graziano da Silva, and kind of a primary author on this. So, what's the FAO saying? They're warning that the food web is coming apart. This is because the biodiversity loss is increasing. So they're stating that the wholesale destruction and degradation of natural ecosystems puts human food security at risk. They also add a warning that the same loss could also seriously affect human health and livelihoods. Now, I oftentimes see these comments of people saying, well, a warmer planet means more plant growth, and that's going to be good. No. Warmer temperatures does not necessarily mean plants will do better, and that more crops will result. I have done stories for you in the past where I share with you that the findings are that warmer temperatures does not increase crop yield. In fact, it may reduce crop yield, and the quality of the plants is less nutritional. Because plants, like all organisms, have preferred temperature ranges that they want to live in. You make it too warm for them, you're going to stress the plants out. And putting aside the C3 and C4 metabolism, that's what it basically comes down to. Now, the conservationists, biologists have been telling us for decades the threat of increasing mass extinction of species and so forth. So the FAO study focuses on what its authors call associated biodiversity for food and agriculture. In other words, the networks or ecosystems of living things that underwrite all human food, livestock feed, fuel, and fiber, not to mention medicines. Very important consideration. These ecosystems include all plants, animals, microorganisms, insects, bats, birds, fungi, bacteria, earthworms, mangroves, corals, seagrasses. You name it, it's there. Which, of course, these organisms help create soil fertility, pollinate plants, purify air and water, feed, protect fish, fight crop, livestock, pests, and diseases. So another team, independent team, also reporting in the journal Nature Climate Change, they have modeled, this is another French team, they have modeled marine biological systems on which humanity's annual 80 million metric ton haul of fish depends, and warned that climate change could be about to trigger what they call unprecedented biological shifts in the world's oceans. In other words, things are going to collapse. For example, I've already discussed with you in prior videos how the phytoplankton, but the planktonic community in general in the Bering Sea has changed. The dominant phytoplanktons used to be diatoms. They prefer cold water to be in. They're being replaced by coccolithophorids, coccolith for short. They prefer warmer. Well, the warmer temperatures affect the zooplankton. So now we're seeing changes in the zooplankton community. Well, the fish that got used to eating certain zooplankton are not finding those zooplankton. They're forced to switch to other zooplankton, and they may not be getting the energy, the caloric requirements. So now those fish don't do well. Maybe they don't grow as well. But here's an interesting thing. Fish, there's an ideal temperature for them to grow in. if temperatures are warmer than that, the fish may survive, but they're actually just burning through their metabolism. So they're using the energy to survive. They're not using the energy to put into reproduction, to form gametes. Here's an interesting twist. This is, kind of an established principle of fisheries science, but if fish are in situations that's too warm for their liking, they actually get stressed out. They'll survive if they do survive, but they won't be able to put energy into reproduction because their metabolism is increased. So they're burning through the energy. So what do they often do? They move. They swim to areas where the temperature is more to their liking. And we're seeing this. So if commercially important fish start moving off because of warming oceans, you're not going to catch them. But if by the time you get to the commercially important species, there may be 1, 2, or 3 trophic levels in between that could affect them even getting enough food for them to grow. If the lower trophic levels are doing poorly, there won't be energy transferred to the upper trophic levels. So there's a whole bunch of things going on, and that's kind of, in essence, what this study is looking at. So the FAO released a 576-page report, and they don't just concern themselves not only with the loss of natural wilderness and the biological variety, biodiversity in other words, but also they looked at the wild ancestor of crop plants, the various strains, breeds, variants, if you will, that have been selected and bred by agriculture practices. Here's some interesting things. There are more than 250,000 flowering plants, basically 250,000. 6,000 are cultivated for food. Okay, so that's like, like 1/40th. Okay. Most of the global diet is based on fewer than 200 species. Okay, 250,000 plants, 6,000 cultivated for food. Most of the global diet is based on fewer than 200 species. So we have basically dropped, 3 orders of magnitude. 66% of all crop production, in other words, 2/3 of all crop production is delivered by just, wait for it, 9 crop plants. So 2/3 of human food, the crops are used for human food, is supplied by 9 plants. That's very tenuous. That's really something happened to several of those crop plants. There's going to be widespread famine with subsequent die-offs. All these 9 crop plants are dependent directly and indirectly on associated to biodiversity. Everything's intertwined. That's how it is, folks. Less biodiversity means that plants and animals are more vulnerable to pests and diseases. Compounded by a reliance on fewer and fewer species to feed ourselves, the increasing loss of biodiversity for food and agriculture puts food security and nutrition at risk. And that's a statement by Jose Graziano da Silva. Nice sounding name. Jose Graziano da Silva. Just kind of rolls off the tongue. Anyway, the FAO authors based their study on data from 91 of the 178 countries represented in the organizations, about half of the countries. They find that 40 animal species comprise the world's livestock, but the vast majority of meat, milk, and eggs come from just a few species. The global count of breeds of livestock is put at 7,745. Of this amount, 26% are at risk of extinction, basically 1/4. Now, in addition, we have the 9 major agricultural crop plants, but there are also some wild varieties, some of those 200 species, right? The fruits, bulbs, tubers, grains, nuts, kernels, saps, gums, honey, insects, snails, right? There's other food. Of course, some of those are obviously not plants, but these are items that people utilize to get the nutrition. 24% of the 4,000 species that provide wild food are in decline. An estimated 87.5% of all flowering plants are pollinated by animals. So, obviously you got the insects, right? So, for example, bees. You got hummingbirds. Okay? And even an animal just brushing past a flowering plant will take some of the pollen from the stamen and place it onto the pistil of the plant. So, crops pollinated by at least partially by animals, bees, insects, birds, bats, account for 35% of all global food, but for more than 90% of available vitamin C and more than 70% of available vitamin A. In other words, the plants that give us vitamin C and A, these animals pollinate more than 90% of those plants. And what do we know about birds? Bees. There's also some dye on the bird. The bees' numbers are dropping worldwide. Bees are our pollinators. The bees die off. They're not going to pollinate our food. Our plants that get our food. This is very serious. Researchers also looked at other functions that the natural ecosystems provide. For example, coral reefs, seagrass meadows, kelp forests provide nursery space, food sources for fish, especially young fish. They also protect coastal communities against floods and storms. You have a big estuary, you have expanses of seagrass. They absorb a lot of the energy when storms move in or when tidal actions move in. Wetlands, forests, grassland regulate water flow. Grazing animals reduce the risk of grassland and woodland fire, and overgrazing is a major driver of soil erosion, soil compactions. So it's a fine balance. You need them to graze, do some grazing, so the risk of fire is reduced, but you don't want them to overgraze because then you have soil erosion. And all these ecosystems are considered to be under extreme stress. A lot of these estuaries and mangroves and swamps and those kind of regions, wetland, they also are cleansers. They're major filters. They filter a lot of the stuff that comes through them. They perform important functions. And what do? Well, that's just a swamp. Clear it out, bulldoze it, stick a mall there or something. Not realizing the ecological importance. And this all contributes to what I keep saying, that we're having more and more people on ever reducing land area that we're trying to grow food, have places of business, have places to live in. We're displacing animals. This is not sustainable. Something will give and snap. It just has to. Just basic ecology 101 principles. And of course, then you toss in, global warming, and that's just going to accelerate extinction rates, in essence. Other researchers have identified the danger of losing the wild ancestors of many crops, further exacerbated by, being stressed out by climate change. German scientists warned in 2017 of catastrophic falls in insect populations, and we're seeing that. The impact of ever higher CO2 level is predicted to cause devastation to the kelp forests that provide shelter for many commercial fish species. Warming itself can only impoverish ocean habitat. Remember, I've discussed with you before, if you need to have productivity, you need two events. You need a vertical overturn of the water column to mix the nutrients, get them up into the photic zone, but then you need a stabilization, basically stratification, the formation of a pycnocline in the ocean, thermocline in freshwater. If you keep the upper layers really much warmer, Remember, warmer waters are less dense. It's never going to sink. You are never going to break down that pycnocline. Eventually, the nutrients will be depleted within the photic zone, and then those ecosystems collapses. And that's basically what's being warned about here. So without that breakdown of the pycnocline to allow the mixing, if you set up this permanent, and it will no longer be seasonal, it will be a permanent shallow water pycnocline, productivity in the upper layers of the ocean where most productivity takes place will basically cease. Other teams from European nations, the US and Japan, have been verifying the findings of the FAO. They've been monitoring ocean biological systems, and trying to do so is, of course, constrained in scale. It's fragmentary, meaning the ocean is a big place. It's very difficult to monitor the whole damn thing, to be quite blunt. And, so it's fragmentary at best. You go here, you go there, wherever you can easily access, get the equipment, the infrastructure, and to carry out the research, and so forth. So what do we see now? More and more computer simulations being done. So some of these researchers, they designed a large number of pseudo-species of marine creatures, from zooplankton to fish, in 14 different ecoregions, all with the range of responses to natural temperature variation, and then conducted kind of like, let's see what the hell happens if this takes place. What if ocean temperatures increase by this amount? See what happens. And basically what they're saying, what they're warning, is that if things continue as they are, expect abrupt community shifts. That's their words. That could end in long-term change in the global catch, meaning landings in tons, metric tons, of fish that's caught for commercial purposes. Even fish farms will be adversely affected. And then, of course, is the big, what will this do to the ocean's role in the carbon cycle? Then you have to factor in, you have to tease out the signals from ENSO, the IPO, the NAO, and so on, to figure out ocean's role in the carbon cycle. The big deal is, trying to, a lot of these studies focus on the role of carbon, how it is cycled through the atmosphere, water, deep water, shallow water, rocks, organisms, etc. A lot of area for research there, and the research team's hard at work. So, I wanted to bring you that report. Kind of sobering, but it is what it is. Thank you for your time. Hey friends, this is Jim reminding you to subscribe and share my videos. Also, don't forget to click the bell so that you know when I drop a video in. And I'm also asking for you to please support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your continued support.